We're starting here with a little check-in problem from 7-4 day 1 before we move on to 7-4 day 2. Just quickly want to review one of these and go over a reference angle and how to rewrite these expressions as a reference angle. Remember, a lot of times this little picture is helpful. We've got a 210 degree angle. Here's the initial side. 210 puts us down in quadrant 3, slightly past 180. But not quite to 270 degrees, which means its reference angle is going to be right here. And the question is, how many degrees is 210 past 180? It would be 30. Okay, so what this means is the sine of 210 degrees, is the same as the sine of 30 degrees, okay, except in terms of sign, meaning positive or negative. Sine of 30 degrees, that's from quadrant 1. That's positive. However, in quadrant 3, where 210 degrees, that's where we find that angle, sine values are negative. So I do have to add the negative sign. Okay, negative times the sine of 30. If you want any more practice with those, feel free to try these other 3 examples. These all should be in degrees. For some reason, I did not fill in a degree symbol, and I should. Certainly go on to try others like that, but at this point we're going to move on to day 2 of 7-4. We're getting to the unit circle, and to do that we want to talk about key points, which are based off of 45, 30, and 60 degree angles. Okay, they come from the 2 what we call special right triangles, the 30, 60, 90. And the 45, 45, 90. We're going to start with the 30, 60, 90, and in particular look at this 30 degree angle. What starts all of this is in a 30, 60, 90 triangle, we see some particular relationships with the side values. The side opposite 30, if that is x, then the hypotenuse is 2x, and the other leg is x times the square root of 3. Okay? Now for 30 degrees, sine is opposite over hypotenuse. So no matter what that value for x is, the hypotenuse will be twice as long. Think of those x's as canceling. And the sine of 30 degrees is 1/2. Let's look at the cosine of 30 degrees. That's adjacent over hypotenuse. Again, the x's cancel. And we get square root 3 over 2. Now to save ourselves some time, we can recognize a little pattern that these values are going to be very similar for sine and cosine of 60 degrees. As a matter of fact, all that's happened is the 2 values switch. You could go through and actually write out the ratio with opposite over hypotenuse for sine and adjacent over hypotenuse for cosine, but you'll see the same thing happen. Now we really just have one that we have to look at here because this case is the only one where they come out to be the same. You can see it doesn't matter if we pick one angle or the other. The opposite side is x and the adjacent side is x. But in a 45, 45, 90 right triangle, whatever the legs are, that's just x. The hypotenuse is square root 2 times x. Okay. So for sine of 45 degrees, we would have x over square root 2 times x. X's cancel, and we get 1 over square root 2. Go ahead and rationalize that, and we get square root 2 over 2. And as I previously mentioned, cosine comes out to be exactly the same. On this slide, we're just making a summary of all these different relationships that we saw. Okay, first of all, for 30 degrees, the sine value was 1/2 cosine square root 3 over 2. Sine of 45 is square root 2 over 2. Cosine is square root 2 over 2. Sine of 60 is square root 3 over 2. Cosine of 60 is a half. Okay? Now what we're going to do is take a look at each one of these separately and get a few more angles on the unit circle that we know from using reference angles. Notice that all these are in quadrant 1 because we're looking at angles that are between 0 and 90. Let's start by looking at the case of multiples of 30. Okay, I had just mentioned that on the previous slide that the cosine of 30 degrees is square root 3 over 2 and the sine value is a half. Now if this angle right here is 30 degrees, that means the coordinate point, assuming this is a unit circle with a radius 1, the coordinate points are square root 3 over 2 for cosine and 1/2 would be the y value for sine. Now these other angles on here are all reference angles. And we talked in the last lesson about how with reference angles, what changes is just the sign as we move from one quadrant to the next. Okay? So in fact, what I can do here is go through and just write in that's square root 3 over 2 comma 1/2, except possibly for sine. That's square root 3 over 2 comma 1/2. And over here in quadrant 4, that is square root 3 over 2 comma 1/2. Okay, now I'm just going through and I'm thinking about quadrants. Okay, for example, in quadrant number 2, x coordinates are negative, so that cosine value for that angle, which is a 150-degree angle, because my reference here is 30, as is this one, and as is that one. Okay, sine value is a half. Down in quadrant number 3, I'm going 30 degrees past 180, so this is a 210-degree angle. X and y values are both negative down there, so those signs should switch. And then down in quadrant 4, I'm looking at a 330-degree angle because it's 30 degrees short of 360. Let me rewrite this one a little more clearly. We have square root 3 over 2 comma negative 1/2. Okay. Now with multiples of 45 and 60, again we're looking at 45 degrees and then all of the reference angles around the unit circle. I should say all the angles that have 45 as a reference. Okay, we saw before, looking at the 45, 45, 90 triangle, that the sine value and the cosine value for 45 degrees is square root 2 over 2. Now let's do the same thing we did here and just go through and fill that in. And at the moment, just pay no attention to having the proper sign. Okay, we'll go back and fill that out in a minute. Right now we're kind of saying we don't care. And the exact same pattern would follow. In quadrant 2, there the x-coordinate would be negative, and remember that x-coordinate corresponds to a cosine value. In particular, it's the cosine value in quadrant 2 of the angle that has 45 degrees as its reference angle. That would be 135. Both negative, just the y-coordinate's negative. Okay. Follows the exact same pattern with the sine and cosine values of 30 in terms of which ones are positive and which ones are negative. Okay, over here with 60, remember here the coordinates switched. Over here in quadrant 2, for this angle, try to leave yourself a little more space than I have. Here we're in quadrant 3. Again, notice I'm paying no attention to sine. I just know that for all these angles that have 60 degrees as a reference angle, that their sine and cosine values are based off of this number. Again, I just have to go back here and change that one should be negative. Down in quadrant 3, both should be negative. And in quadrant 4, the y value should be negative. Okay, and again, all of those, you'd have to go through, and you can kind of think it through to see which angle is which. In quadrant 1, it's 60 degrees. And now over here, in quadrant 2, this is an angle that has a cosine value of negative 1/2 and a sine value of square root 3/2. It's in quadrant 2, and its reference angle is 60 degrees. So this angle right here is 120 degrees. Okay, and you can do that with all those to kind of figure out these various angles. Now comes the moment to put it all together. I'm going to defer to you for a little bit of this, all right, because it's actually something I want you to try on your own, and if you get stuck, you can check with me in class. I'll give you all the angles that you'll need, okay? Basically what we're doing here is we're taking the 3 diagrams that we just looked at, and we're putting them all together as one, all right? I just want to make sure you've got the correct angle values based on the reference angles that we looked at before. We've looked at 3 key angles. Okay, up here we have 90 degrees. And this is where we got into reference angles. Okay, this first angle in green, that was 120 because it had a reference angle of 60. The one in red is 135, and the one in blue is 150. Okay, and of course we hit 180. Then we go 30 degrees past. That's 210. All the lines that are in blue are corresponding to reference angles of 30. All the ones in red have reference angles of 45. All the ones in green have reference angles of 60. There's 270. $300, $315, and $330. Okay? What I want you to do on your own here is to go through now and on the previous diagrams that we made, because we essentially already, for the most part, made the unit circle. We just broke it down to 3 separate diagrams. Put all the sine and cosine values in their appropriate places. For example, with square root 3/2, it's cosine, for the angle that's 30 degrees, its cosine value is square root 3/2, its sine value is 1/2. Okay, so go ahead and mark all those points and mark those angles in radians. Okay, again, try that on your own. If you get stuck, be sure to talk to me about it in class. Here's a little preview for the kind of homework problems that you're going to get. And these are all going to come from the unit circle. I want you to try these on your own, but I do want to give you a couple pointers here before you try these. Make sure your unit circle is complete and ready to go before you try these. And also remember that on that unit circle, it's always worth reminding yourself that the x-coordinate of that point corresponds to a cosine value. The y-coordinate represents a sine value. Okay? So once you have your unit circle complete, I would go and check at 210 degrees, what is the x-coordinate at that particular point. Okay? It just so happens that for that one, it's negative square root 3/2. Okay? That's what you're looking for. Same thing, but you could have an angle that's in radians. All right? Pi/3 is the same as 60 degrees. All right? You could see one that's negative. If you want to think about it as a coterminal, open up 60 degrees clockwise, or you could go 300 degrees counterclockwise. You just need to know that negative 60 and 300 are the same thing. All right? Same thing with negative 240. Know what angle on the unit circle that corresponds with. Okay, it happens to be there. Negative 240 is the same as positive 120. Just opening the opposite way if it's negative. Let's see, that'll be all for 7-4, day 2. Again, try that unit circle on your own. Really, the whole theme of the homework assignment is evaluating key points off the unit circle once you have a good, accurate unit circle constructed and put into your notes.